everyone, and welcome to the Deep Dive. So many of you shared this article, and it's got a really dramatic title, right?
Yeah.
The 20 Lies About Astronomy and Science That You Still Believe.
Yeah.
And we thought...
Yeah, it's pretty clickbaity.
It is so clickbaity, but we thought it would be fun to unpack it together and see if we can separate fact from fiction.
Exactly.
Who knows? Maybe we'll even bust a few of our own misconceptions along the way.
Always fun to challenge what we think we know.
Yeah, for sure. So let's dive right in.
Let's do it.
Okay, so this first one, I think we've all kind of fallen for it at some point.
Mm-hmm.
You know, how many times have you seen astronauts floating in the International Space Station and thought, oh, zero gravity?
Classic image.
Right, but is that actually true? Is there really no gravity in space?
Well, not at all. It's one of those things that just seems so counterintuitive. But gravity exists everywhere in the universe.
Yeah.
It's kind of mind-blowing when you think about it.
It is.
Like, gravity is what holds galaxies together, keeps planets in orbit.
Yeah.
And, yeah, even causes you to drop your phone from time to time.
Oh, yeah. Definitely experienced that a few times. So, okay, if it's not zero gravity, then what's going on with those astronauts floating around?
What they're experiencing is called microgravity.
Okay.
And imagine being in an elevator that's constantly falling.
Oh,
That's kind of what it's like for astronauts in orbit.
I see.
They're continuously falling towards Earth, but they're moving forward so fast that they just keep missing it.
So they're like falling in a perpetual loop around the planet.
Exactly. It's
They-
like falling but never hitting the ground.
Okay, that makes a lot more sense. I always pictured it as just floating in nothingness, but it's more like a constant free fall.
Right.
That's amazing.
It is. And here's another mind-blowing fact. You have gravity too.
Wait, what?
Yeah, it's incredibly weak compared to Earth's, obviously.
Right.
But every object with mass exerts a gravitational force.
Oh, wow.
It just takes an enormous object like a planet to have a noticeable effect.
So technically, we're all pulling on each other with our own tiny gravitational fields.
Exactly. We're all connected by gravity in a way.
That is wild. Okay, let's move on to a myth that's been the subject of countless debates and conspiracy theories.
Oh, here we go.
The moon landing. Did it really happen?
Oh, this one. It's amazing how this one persists, but the evidence overwhelmingly suggests that yes, it did happen.
Okay, so what kind of evidence are we talking about?
Well, we've got physical proof, like the lunar samples brought back from the Apollo missions.
Right.
These rocks have unique compositions that could only have formed on the moon.
Okay.
And then there's the laser reflectors left on the lunar surface. Scientists still use these today to measure the distance between the Earth and the moon with incredible accuracy.
So it's not just about those grainy photos and videos we've seen.
No, not at all. There's tangible scientific evidence that supports the moon landing. And, independent researchers and scientists from around the world have corroborated these findings.
So there's really no room for doubt.
Not really. The evidence is pretty conclusive.
Okay, well, that settles that. Speaking of things that make you question what you thought you knew, I bet you think a day is exactly 24 hours long.
Uh-huh. I see where you're going with this. Another common misconception.
It is. While we use a 24-hour clock for convenience, a day, measured by the time it takes Earth to complete one rotation, is actually 23 hours and 56 minutes long.
Yeah, a little bit shorter than we think.
So how do we end up with a 24-hour day then? It seems like our timekeeping is a bit off.
It's because our 24-hour system is based on the time it takes for the sun to return to the same position in the sky, which is slightly longer than one full rotation of the Earth.
Oh, I see.
It's a subtle discrepancy, but it highlights how our timekeeping system has to account for Earth's actual rotation. That's also why we have leap years, to keep our calendar aligned with the Earth's revolutions around the sun.
Oh, so it's like our calendar is playing a cosmic game of catch-up.
Uh-huh, that's one way to put it.
Okay, here's one I've heard countless times growing up. Humans evolved from monkeys. Is there any truth to that statement?
It's definitely a simplification. It misses a lot of nuance.
Right.
We didn't evolve directly from monkeys as we know them today, like chimpanzees or gorillas.
Right.
Instead, we share a common ancestor with modern apes that lived millions of years ago.
Oh, okay.
Over time, our lineage diverged, leading to the evolution of hominids.
Hominids?
Yeah, hominids are an ancient primate family that includes our direct human ancestors.
So it's more like we share a distant relative way back when rather than coming directly from modern monkeys.
Precisely. And what's even more fascinating is that there were actually multiple human species within the Homo genus, but only Homo sapiens, that's us, survived.
Whoa, so there could have been other human species walking around.
Imagine a world where different human species coexisted. That would have been interesting.
Yeah, that would be a truly diverse family reunion. Okay, time to tackle another widely held belief, the idea that the Great Wall of China is the only human-made structure visible from space. Have you ever wondered if that's actually true?
It's a myth that has persisted for a long time, but the reality is a bit more complex. While the Great Wall is incredibly long, it's actually quite narrow and blends in with the surrounding landscape when viewed from orbit.
Huh.
Astronauts have reported that roads and even the pyramids of Giza are easier to spot from space because they offer more contrast against their surroundings.
So it's not just about size, but about visibility and contrast.
Exactly. Sometimes the things we assume are the most prominent aren't actually the most noticeable from a different perspective.
That's a great point. It makes you wonder what other assumptions we make that might not hold up under closer examination. Now let's shift our focus to our cosmic neighborhood, the solar system. What do you think of when you hear that term?
I think most people tend to picture the sun and the planets neatly arranged around it, like a model you'd see in a classroom.
Yeah, that classic image.
But that picture is just a tiny snapshot of a much larger and more dynamic system.
You're saying there's more to our solar system than just the planets we learned about in school?
Way more. The solar system extends far beyond the orbit of Neptune, encompassing a vast region of icy bodies, dwarf planets, and a cloud of comets. It stretches out for about 100,000 astronomical units. To give you some perspective, that's like traveling to the sun and back 100,000 times.
Whoa, so our solar system is more like a sprawling cosmic metropolis than a neat little neighborhood?
Exactly. It's vast and full of surprises.
I had no idea it was that vast. Okay, let's talk about one of the most famous stories in science. Newton and the apple. Did he really get hit on the head and have a eureka moment about gravity?
It's a great story,
Hmm.
right? But the truth is probably a bit less dramatic. There are accounts from people who knew Newton that mention him observing a falling apple, but there's no real evidence to suggest he was bonked on the head. It's more likely that the apple story is a simplification of a much longer and more complex process of scientific discovery.
So no magical apple-induced revelation?
Probably not.
Yeah.
Even brilliant minds like Newton's don't just stumble upon groundbreaking discoveries in a single moment. It takes years of observation, experimentation, and refinement to develop a deep understanding of the universe.
Right, observation and experimentation are key. Speaking of things that happen in the universe, what happens to the human body in space without a spacesuit?
Oh, that's a good one. Contrary to what you might see in movies, you wouldn't explode.
What?
You'd lose consciousness within seconds due to lack of oxygen,
Okay.
and your body would experience some swelling because there's no air pressure to counteract the fluids in your tissues. But you wouldn't burst. The real danger in space is the extreme temperatures and radiation, which would quickly lead to death.
So it's a less dramatic but equally fatal experience.
Exactly.
All right, let's debunk another myth that's been around for ages. Does a full moon really make people act crazy?
This one always comes up.
Mm-hmm.
Despite what folklore might tell you, there's no scientific evidence to support the idea that the full moon causes people to act strangely. Yeah, it's a persistent belief. But numerous studies have consistently shown that there's no correlation between the lunar cycle and human behavior, crime rates, or hospital admissions.
Huh, so we can blame our bad decisions on ourselves, not the moon.
Exactly.
Yeah.
We're responsible for our own actions.
Okay, good to know. All right, let's get a little more abstract. Gravity. We're taught that it's a force that pulls things down, but is that the whole story?
Well, that's how Newton described it. But Einstein revolutionized our understanding of gravity with his theory of general relativity. He proposed that gravity isn't a force in the traditional sense, but rather a curvature of space-time caused by mass and energy. Imagine a bowling ball placed on a trampoline. It creates a dip in the fabric, right?
Right.
That's essentially what massive objects do to space-time.
So gravity is more like a warp in the fabric of reality.
That's a great way to think about it.
That's mind-blowing. Okay, let's talk about another big one, the Big Bang. It's often depicted as a giant explosion, but is that accurate?
Not quite. The Big Bang wasn't an explosion in the traditional sense. It was an expansion of space itself from an incredibly hot and dense state. Think of it like a balloon inflating, rather than something bursting outward into pre-existing space.
So the universe itself is the balloon, and
Yeah.
it's been expanding ever since that initial moment.
Precisely.
Incredible. Okay, time for a little cosmic color correction. What color is Mars, really?
Ah, the red planet. It was
Er-
called that for a reason, right?
Right.
But Mars is more than just a uniform shade of red. While it does have iron oxide, which gives it a reddish hue, images from rovers and spacecraft have shown that it actually has a more diverse palette. There are shades of brown tan and even hints of gold in the Martian landscape.
So Mars has its own unique color scheme. like an earthy cosmic palette.
Exactly. It's a beautiful and diverse planet.
Very cool. Now let's talk about the Milky Way. Why is it called that?
The name comes from its appearance as a faint band of light stretching across the night sky. The ancient Greeks saw it as a stream of milk spilled across the heavens by the goddess Hera. Of course, we know it's not actually made of milk.
Right.
But it does contain vast amounts of gas, dust, and stars, creating that milky appearance.
That's beautiful. It's amazing how even scientific names can have their roots in mythology. Speaking of colors, what color is the universe itself?
You might be surprised to learn that it's not just black. Research suggests that if you could combine all the light from every star and galaxy in the observable universe, it would create a subtle beige hue.
Beige.
Yeah, scientists have even nicknamed it cosmic latte.
Haha. So the universe is more like a warm, inviting latte than a cold, dark void.
Exactly, a very cozy universe.
I love that. Okay, here's another space myth I've always wondered about. We always see the asteroid belt depicted as this densely packed minefield of space rocks. Is it really like that?
Not at all. Hollywood likes to take liberties with these things.
Of course they do.
In reality, the asteroid belt is incredibly vast, and the asteroids are actually quite spread out.
Mm.
The average distance between them is about 13 times the distance between the Earth and the Moon.
Yeah.
So while there are millions of asteroids, the chances of a spacecraft colliding with one are actually quite low.
So it's more like a cosmic scattering of pebbles than a dense rocky barrier.
That's a much better way to picture it.
Okay, let's delve into those mysterious cosmic beasts, black holes. Do they really suck everything in like giant vacuum cleaners?
That's a common misconception.
Mhm.
Black holes have incredibly strong gravity, but they don't suck things in any more than a star of the same mass would. Objects can orbit a black hole stably for a very long time without being pulled in. It's only when an object crosses the event horizon, the point of no return, that it's inevitably drawn into the singularity at the black hole's center.
So it's more about an object's trajectory and proximity to the event horizon than a black hole actively sucking things in.
Exactly. Black holes get a bad rap.
Yeah, they do. All right, one last myth to bust before we move on. Could we really blow up an asteroid heading for Earth with a nuclear weapon like we see in the movies?
It makes for a dramatic scene, but in reality, it's not that simple. A nuclear explosion wouldn't vaporize a large asteroid. It might break it into smaller pieces.
Whoa.
But those pieces could still pose a threat to Earth. Scientists believe that a more effective strategy might be to nudge the asteroid off course using a gravitational tugboat or a kinetic impactor.
So dealing with potential asteroid threats requires a bit more finesse than just blowing things up.
Yes, it would require careful planning and a deep understanding of orbital mechanics.
Well, this has been incredibly insightful. We've already debunked so many commonly held beliefs about space, but don't worry, there are plenty more myths to bust and insights to uncover. Let's take a short break and we'll be back to continue our deep dive into the fascinating world of astronomy and science. And we're back for more deep dive.
We're on this mission, to debunk those space myths, those ones that just won't quit.
It's like they have their own gravitational pull or something.
They really do. And it's kind of crazy how some of these have stuck around for so long.
Yeah, you'd think with all the information we have these days that we'd be past this. You'd think so. But hey, that's why we're here, right?
That's right, to set the record straight.
Exactly. So speaking of things that might surprise you, we often imagine planets, just neatly orbiting the sun like clockwork.
Right.
But you mentioned earlier that Jupiter being the giant, it actually affects the way the sun moves.
It does. It's pretty wild, actually.
Okay, so break it down for us.
So Jupiter is so incredibly massive that its center of gravity with the sun isn't actually located within the sun itself.
What?
Yeah, it lies just outside the sun's surface.
Seriously?
Seriously. So both Jupiter and the sun are orbiting around this common center of gravity.
So it's not just Jupiter going around the sun, they're both kind of like dancing around each other.
Exactly. It's a cosmic waltz.
That's one way to put it. But wait, so how do we not notice this? I mean, the sun seems pretty stationary to us.
Well, it's a subtle effect.
Okay.
Jupiter's gravitational influence causes the sun to wobble slightly as they orbit their common center of gravity.
It's like Jupiter has enough gravitational pull to make the sun do a little jig.
Uh-huh. You got it.
Okay, so from cosmic waltzes to something a little more down to earth, this has been in the news a lot lately, climate change.
Yeah, a big topic.
Huge topic, and there's still a lot of debate and misinformation swirling around it. But what's the scientific consensus on what's actually happening to our planet?
Well, the overwhelming scientific evidence points to the fact that human activities, primarily the burning of fossil fuels,
Right.
are releasing greenhouse gases into the atmosphere.
Okay.
And those gases trap heat, causing the planet to warm at an unprecedented rate.
So we're basically turning up the thermostat on Earth.
It's a good analogy.
And what are the consequences of that?
Well, this warming is leading to all sorts of effects. We're seeing melting glaciers, rising sea levels, more extreme weather events like hurricanes and droughts.
So it's pretty serious stuff.
Yeah, it's a global challenge that definitely requires our attention and collective action to mitigate the impacts.
Absolutely. Okay, so let's shift gears again and travel back in time to ancient Egypt.
Always love a good time travel trip.
Yeah. Right. Have you ever heard the theory that aliens built the pyramids?
Uh-huh. Oh, man, that's a classic.
It is. So what's the truth behind those magnificent structures?
While the pyramids are incredibly impressive feats of engineering,
They are.
there's no credible evidence to suggest that extraterrestrial intervention was needed.
So how did the ancient Egyptians manage to build these massive structures without the help of aliens?
They were incredibly skilled architects, engineers, and builders. I mean, they developed sophisticated techniques for quarrying, transporting, and lifting massive stones.
Wow.
We have evidence of the tools they used, the ramps they built, the organizational structures they put in place to manage these large-scale projects.
So no alien spaceships or tractor beams?
Nope, just human ingenuity and a whole lot of hard work.
That's amazing. It's mind-blowing to think about the ingenuity and collaboration that went into creating these monumental structures.
It really is. It highlights the importance of understanding our past and appreciating the achievements of those who came before us.
Absolutely. All right, so we talked about the pyramids, but what about the Sphinx? What's the story behind that mysterious creature with the lion's body and human head?
Ah, the Sphinx. It's one of the most iconic monuments in the world.
For sure.
It's this massive statue carved out of a single block of limestone.
Right.
And its exact purpose, its symbolism, are still debated today.
So we don't really know for sure why it was built.
We have a lot of theories.
Okay.
Some believe it was a representation of the pharaoh Khafre, who ruled during the time it was built.
Yeah.
Others see it as a symbol of royal power, divine protection, or even as a guardian of the afterlife.
It's like a giant riddle frozen in time.
I like that. A giant riddle frozen in time. It really is a reminder that the past is full of mysteries.
It is. Okay, back to space. This one has always bugged me. If the universe started with the Big Bang, wouldn't it be perfectly smooth and even?
That's a great question. It gets to the heart of how we understand the early universe.
Okay.
So if the Big Bang had been perfectly uniform, then yeah, the universe might look very different today. But the early universe wasn't perfectly smooth. There were tiny fluctuations in density and energy.
Yeah.
And those minuscule variations ultimately led to the formation of stars, galaxies, and the large-scale structures we see today.
So you're saying that those tiny imperfections are what gave rise to everything we observe in the universe?
Exactly. Those initial quantum fluctuations were amplified over billions of years as gravity pulled matter together. The denser regions attracted more matter, eventually collapsing to form stars and galaxies, while the less dense regions expanded into the vast cosmic voids we see between those structures.
It's amazing to think about. It's like those tiny seeds of structure billions of years ago shaped the entire cosmos.
It really highlights the interconnectedness of everything in the universe.
It does. Okay, last one for today. And this one is a little more down to earth.
Yeah, bring it on.
Have you ever heard that you can only fold a piece of paper in half a maximum of 7 times?
Ah, that's a classic.
It is. So is it true?
Well, it's not entirely true. The sevenfold limit is more of a practical limitation than a hard and fast rule.
You mean you can actually fold a piece of paper more than 7 times?
Technically, yes.
Really?
It becomes increasingly difficult with each fold because the thickness increases exponentially. But with enough paper force and ingenuity, it has been done.
No way.
Yeah. In fact, in 2002, a high school student named Brittany Gallivan managed to fold a single sheet of paper in half
Wow.
12 times.
12 times.
12 times.
That's amazing.
That's incredible. So it's more about the physical limitations of the material and our ability to apply force than a mathematical impossibility.
Exactly. It's a good example of how perceived limits can sometimes be broken with a bit of creativity and determination.
That's a great point. I think we've successfully busted quite a few myths today, wouldn't you say?
I think so.
Yeah.
It's been a really fun journey through some of the most common misconceptions about space science and even everyday phenomena.
What would you say is the biggest takeaway from all this?
I think it's to cultivate a healthy skepticism. Don't be afraid to question things you hear or read.
Even if they sound convincing.
It's exactly. Dig a little deeper look for evidence and be open to changing your mind when presented with new information.
Great advice for navigating the world of information overload.
Absolutely.
We should all strive to be lifelong learners, constantly challenging our assumptions and expanding our understanding of the world.
So to our listeners out there, keep those minds curious and those questions coming.
The journey of discovery never truly ends.
Couldn't have said it better myself. Thanks for joining us on the deep dive, and we'll catch you on the next one.
Welcome back to the deep dive. We're back for round 3, busting more of those space myths.
It's like they never end.
They really don't. But hey,
Yeah.
that's what keeps things interesting, right?
Absolutely. Always more to learn and unlearn.
Exactly. So, ready to tackle a few more?
Bring on.
All right, let's talk about those magnificent structures from ancient Egypt again.
Okay, back to the pyramids.
We talked about how they weren't built by aliens, but have you ever wondered about the Sphinx?
Oh, the Sphinx.
What's the story behind that mysterious creature, with the lion's body and human head? Yeah, the Sphinx is one of the most iconic and enigmatic monuments in the world.
Wow.
It's a massive statue carved out of a single block of limestone.
Right.
And its exact purpose and symbolism are still debated today.
So we don't really know for sure why it was built.
There are many theories, but no definitive answer.
Yeah.
Some believe it was a representation of the pharaoh Khafre, who ruled during the time the Sphinx was built. Others see it as a symbol of royal power, divine protection, or even a guardian of the afterlife.
It's like a giant riddle frozen in time.
I like that. A giant riddle frozen in time. It's a reminder that the past is full of mysteries that we're still trying to piece together.
It is. Okay, back to space. This one has always bugged me. If the universe started with the Big Bang,
Yeah.
wouldn't it be perfectly smooth and even in all directions?
That's a good question, and it gets to the heart of how we understand the early universe. If the Big Bang had been perfectly uniform, then yeah, the universe might look very different today.
Mhm.
But the early universe wasn't perfectly smooth. There were tiny fluctuations in density and energy, and those minuscule variations ultimately led to the formation of stars, galaxies, and the large-scale structures we see today.
So you're saying those tiny imperfections are what gave rise to everything we observe in the universe?
Exactly. Those initial quantum fluctuations were amplified over billions of years as gravity pulled matter together. The denser regions attracted more matter, eventually collapsing to form stars and galaxies, while the less dense regions expanded into the vast cosmic voids we see between those structures.
It's incredible to think about, those tiny seeds of structure billions of years ago shaped the entire cosmos.
It really is. It highlights the interconnectedness of everything in the universe.
It really does. Okay, last one for today, and this one's a little more down to earth.
Okay, hit me.
Have you ever heard that you can only fold a piece of paper in half a maximum of 7 times?
Oh, like a classic one. And it's actually not entirely true.
Yeah, really?
Yeah, the 7-fold limit is more of a practical limitation than a hard and fast rule.
So you mean you can actually fold a piece of paper more than 7 times?
Technically, yes. It becomes increasingly difficult with each fold because the thickness increases exponentially. But with enough paper force and ingenuity, it has been done.
No way.
Yes. In fact, in 2002, a high school student named Brittany Gallivan managed to fold a single sheet of paper in half 12 times.
12 times.
That's amazing. It is. It just shows you what's possible when we challenge those perceived limits.
Wow, I think we've successfully busted quite a few myths today.
We've made a dent in that list for sure.
Yeah, we have. What would you say is the biggest takeaway for our listeners?
I think the key is to always be curious.
Yeah.
Don't just accept things at face value.
Question everything.
Exactly. Dig a little deeper, look for evidence, and be open to changing your mind when presented with new information.
That's great advice, especially in today's world where information is everywhere.
It is. We need to be critical thinkers and discerning consumers of information.
Couldn't agree more. Well, I think that about wraps up our deep dive into these space myths.
It's been a fun ride.
It has. And to our listeners out there, thanks for joining us on the deep dive. Keep those minds curious, and we'll catch you next time for another exploration of the universe and beyond.